driving where production is occurring. Okay. So what are the long-term impacts? Well, the long-term impacts is it really is helping out in our energy production in this country. And so that is taking away a lot of our dependence on foreign oil. But at the same time, we are also stewards of the environment. And we have to worry about possible environmental impacts that may not be able to be fixed in the short term. And I want to stress again that I feel that water is one of our major resources that we mine and depend upon in this state. And I think we've got a lot to learn from what's going on in a number of our neighboring states. In some of their, what I might call very high rates of production, for example, in Pennsylvania, we're beginning to see, not just from the probabilistic failure of some of the systems, but a more systematic failure in some cases where probably long-term environmental damage will take place. Water is an essential part of hydrofracking. It requires a tremendous amount of water, and I'll show you some figures on that. So one of the first things is, do we have enough water available? I've been reassured by Hal that every time they do this, they have to do a site assessment and determine what available water and what its impact is going to be on a local region in terms of that water resource. And that's just taking out the water to shove in the ground the first time. But what I'm going to point out is it's not just putting it in one time. They actually then have to pull it out to actually retrieve this gas. And associated with that water that we retrieve, in fact, we're going to see there are a lot of dissolved contaminants and also additives that are put into there. So there are some negative effects, and as long as you folks, the legislatures, can ensure that the regulations that are necessary to protect this resource, are we stringent enough? Do we know enough to actually keep these resources protected? I mean, that's where we need your responsible action. Here's just a couple of figures. Barnett Shale, don't have the Michigan, the Antrim values on here. But you know, we're talking drilling the well, you know, drilling mud and so forth, a lot of water. But the hydrofracking, 3.8 million. So we're talking a lot of water being utilized in this. If we actually look at the Collingwood Shale, with that test well, over 5 million gallons of water for that single well. It was 6,000 feet or something of horizontal drilling. It's, you know, just recognize each of these wells requires this volume of water. Do we have it? Is it affecting our ability to, for local regions? The other question is, what do we do with the water we're getting ready to put down there? We're going to see they put a lot of additives into that water. And again, it's to kill things, biocides, to lubricate, isopropyl alcohol, acids, mainly hydrochloric acid, to actually deal with some of the scale and also to make a few more holes and if there's carbonate in the rock. There are lots of things we don't really want to be mixing in our drinking water. In cases where they actually have surface pits which are lined, you know, sometimes this would be the reservoir from which they draw that water and then eventually put it into the ground and then retrieve it and put it in another pond. I understand from Hal that we, in fact, in this state require that all withdrawn water is actually in storage containers. So there's no surface storage. And that's important because I think Michigan's learned its lesson with the Paul Scientific Place. Ann Arbor's got this big plume of pollution because one of these storage ponds where they were storing essentially byproducts from their filter manufacturing process leaked, and dioxane essentially has contaminated large parts of the subsurface in the Ann Arbor area. So we need to make sure that we handle this water properly, both before it's put in and as it's taken out. I put this up here just to sort of give you a sense of what they're putting in here. Lots of different things. Some of the things we don't know because they're proprietary, but some we know in terms of certain acids and scale inhibitors. And you can see that for the most part, these are pretty small percentages, 0.5% to 2% of the total volume of liquids that are put in the ground. But then I want to stress, how many millions of gallons, Janice? 5 million. It doesn't take long to sort of say, but even if we had 3 million at 0.5%, that's 15,000 gallons of things we really don't want mixing in our water. So we do need to make sure that we're not leaking, we're not contaminating, that we're disposing of these things properly. I have not heard of many problems with the actual drilling, rupturing of the casing. I imagine it can happen. Realize that in order to rupture or to frack a layer, you've got to raise this entire drilling assembly up to that pressure. And so even though drill a hole, case it, cement it, case it again, extend that all the way to the bottom hole, in fact, one worries about if we break or rupture these pipes anywhere along, rather than protecting these surface aquifers, in fact, they could become contaminated by such an accidental mechanical failure. I know this happens with cement occasionally. I think there was a big disaster, Maconda rig. They had some cementing problems apparently in that Gulf well. So things can happen. I think engineering and proper regulatory and super, whatever you call it, people who watch make sure they're doing the regulations properly. I think if we do that, that's fine. Recognize this process of fracturing expands. It's occurring because we're expanding that layer. And ideally, that expansion only occurs within the layer of interest. But in reality, if you put 5 million gallons of water in a well, everything's expanding. It's possible to develop what we call cross-stratal fractures. In other words, to actually break through layers which otherwise confine those waters at depth and keep them from mixing into shallower waters. The question is, how far do they go up? Some of our researchers actually looking at deep basinal waters in Michigan using noble gases, things like argon and xenon and radon and so forth, and helium, actually been able to document a fair bit of natural cross-formational flow. And as a result of that, if one then breaks through and connects to some pre-existing sort of fracture systems, you've created a conduit that potentially can bring that contaminant up into our drinking water reservoirs. An example, this is a paper in tectonophysics. This is actually in Western New York. And this was a map, a reconstruction of a lot of subsurface fracture systems, giving you a sense that fractures are not rare in geological formations. So we always have to worry about the potential of cross-formational flow and contamination. I like this figure. It's from the DOE primer on shale gas. And let me explain what the scale is here. This is the base of sort of the drinking water level. This is the target. That's where they're trying to drill down to actually produce material. And this is the thickness of rock intervening, protecting us in effect. And so we can see places like the Barnett Shale and the Fayetteville, Woodford. We've got a pretty good insulating sort of barrier. If we begin looking at Michigan, certainly for the antrim, you know, we're talking a very, very thin interval of protection. Again, I don't think it's a worry for us. I don't want to have people panic on this, in part because the antrim in its own right has lots of fractures, and it was producing through this natural, it's a waterlogged shale to begin with. When we get down to the Collingwood, in fact, we're looking at something much, much deeper. Okay, and so again, we're going to have to worry about possible contamination. Realize that when they do pull that water up, there's lots of stuff in it. And I know that it's fairly clear that when we put all these chemicals in the water and pull it back out again, that is a contaminated water and is dealt with as a wastewater. It's my understanding that in Michigan, we're actually re-injecting that into separate and deep aquifers. And as long as those maintain their integrity, that's a good place to put it. It's better than what's been happening in Pennsylvania and in parts of Wyoming that I know of, where in fact they either just put it in the streams or they ended up running it through traditional wastewater treatment plants, which are not built and designed to remove these kinds of contaminants. Of these contaminants, there's an interesting thing. Black shales, the layers full of organic material that we actually are exploiting, that we want, also have a tendency as they form to pull out heavy metals out of the water and radioactive elements. as an oil geologist, I remember going down and we used something called a gamma log, and you can always tell when you hit one of these black shales because they're always have a much, much higher radioactive sort of background. In fact, these radioactive elements are also leached into these wastewaters. And so we're not only dealing with chemical, elemental contaminants, salty waters, but we're also dealing with radioactive waters. And so they have to be dealt with in a totally different fashion. And we can go through, and this will be available on the TV and web, presumably. But the main thing is we are seeing these kinds of problems developing in some of these highly hydrofracked regions. What do we need to do? And this, again, is a challenge to you folks. I don't know legislation well. If I did, I might try to do it, but I don't think I'd do it as well as you folks. It's in your blood. You understand it. I do understand the physical problems that deal with the science. We need wastewater's, I think, the most critical problem right now in my mind. And ensuring that the regulatory system is such that we make certain that a fly-by-night drilling company properly make sure that they keep their wells cased properly and so forth. In the end, what I'd really say more than anything is that we need to learn from these other states that are extensively exploring in this fashion. We'll learn a lot from Pennsylvania. We're seeing contamination occurring there now. We will learn proper practices from the technology side, and new technologies will be developed to actually handle a lot of this wastewater problem. I would also like to sort of stress that it would be very useful, talking to my colleagues in Pennsylvania, they're just starting it, it's a little late, to actually have what we call an environmental background. In other words, we know in Michigan now there are places where you can turn on your faucet and you get a little methane. There is gas seepage naturally through these cross-formational flow. But where are those natural seepages versus where are those that are actually produced in response to extensive hydrofracking? We need to have this environmental background. A number of us are talking about trying to get together with some of the chemical environmental engineers as well as our own geochemists and organic chemists to actually begin to think about a survey just on essentially shallow water, rural well water, just to get a good coverage to understand what that background is before extensive drilling takes place. I think we have time. Fortunately, the economy and the price of gas is so low right now that probably they're not going to extensively frack the Collingwood in the near future. That gives us time. That doesn't hurt us. If we go ahead with it now, we extract that resource. If you leave it in the ground, it's not going to deplete on its own. It's like putting gas in the bank. Okay? It can stay there until we understand the technologies better, until we understand and develop the technologies and the know-how of where we need to dispose of these wastewaters, to do it in a safe and environmentally conscious way, a sustainable way. And with that, I'll end and thank you all, and I'll take any questions. Yes?
You talked about gas in the shales, but is there any, can you bring up oil as well?
Well, you can, it depends upon the history of that shale. I think they brought up something called condensate, and those are essentially liquid hydrocarbons. You can think about it as sort of natural light gasoline. So the shales ultimately, in their history of being buried, generate initially oil, and they can produce, you just fracture off some CH4s from that and produce a whole series of gases. But if you take oil and bury it too deeply, then you basically break down, and it's like putting it through a refinery. You break down those long-chain hydrocarbons and produce methane and propane and butane, a lot of light gases. So I don't think there's a lot of oil potential in the, Hal? You know a bit more.
The Bakken in North Dakota is basically an oil, I don't know if it's mineralogy or quite a shale, but it's very similar to that anyway. And they're using hydraulic fracturing there to extract the oil. So it's got some potential.
It depends on if it's buried too deeply, they become thermally too mature to have oil. And what it does is just, we call it thermocatalytic breakdown or thermogenic gas.